In this video, we will talk about the median, the right bisector, and the altitude. Now, we are going to work with the algebra in a bit, but to be honest with you, the most important part with the median and the right bisector and the altitude is to be able to draw it first, okay? Once you're able to draw it, the math is much easier because the steps that are required to find the equation of a line that contains a median, for example, will be much simpler once you are able to visualize what a median is, okay? So let's start off by writing the definition, and then I'll draw the medians in the diagram. Okay, so median, by the way, is the easiest one of the three because you should have learned it last year in grade 9 math, because you learned what the median does to a triangle. We're going to talk about it again in this chapter, but you should remember what it does from last year. Okay, so without any further ado, the median is a line segment from a vertex to midpoint of opposite side. So the median is a line segment from a vertex to the midpoint of the opposite side. So if you follow with that definition and imagine you have a triangle, okay, you start from a vertex, you join to the midpoint of the opposite side, you should be able to take this triangle and draw 3 medians. Okay, so I'm going to draw a median from vertex A. Okay, you could draw one from vertex B, from vertex C. I'm going to start one from vertex A. So from vertex A, somewhere about there. Okay, so I know this is the median because I begin from vertex A and it joins the other side. Well, it joins at the midpoint of BC, okay, at the opposite side. It joins at the midpoint of the opposite side. So hopefully you can pause the video and try to draw the median from vertex B and the median from vertex C. So you can unpause, and hopefully our medians look the same. Okay, so we drew the median from vertex A, from vertex B, and from vertex C. So no matter what triangle you're given, you can always draw your 3 medians, whether it's from vertex A, B, or C. Now, hopefully you've also noticed that there's a special point. Okay, if you drew your medians really nicely, you should notice that the 3 medians intersect at a point. Now, this point is very special, which we'll talk about later, but for now, I just want you to remember that the name of the point is called the centroid. The centroid is where the 3 medians intersect. Okay, so no matter what triangle you have, you should be able to draw the centroid of the triangle by drawing in the 3 medians. Where they intersect is a centroid. Okay, next one we have is called a right bisector, or some people call it a perpendicular bisector. Either or, they really mean the same thing. So a perpendicular bisector is a line which, by the way, the name really gives it away. It's a perpendicular bisector. So it's a line which bisects a line segment at 90 degrees. Okay, so you know what? Let's draw a line segment here. Let's call this line segment AB. And let's draw the right bisector, or the perpendicular bisector. So you want to bisect it at a 90 degree. There you go. So I've drawn the right bisector of AB. Now, with this triangle, so I can draw the right bisector of AB, I can draw the right bisector of AC, and I can draw the right bisector of BC. Okay, so you know what, I'll start off by drawing the right bisector of BC. Somewhere about there. Okay, so it's very important you remember that the right bisector does not have to go through vertex A, B, or C. So don't force it to go, because that's a very common mistake that students make. They force the right bisector to go through vertex A. That would be a very bad idea. Okay, so pause the video and try to draw the other two right bisectors. Hopefully ours look the same. So I'm just looking at I'm looking at my first right bisector of BC. Okay. Okay, so that's right bisector of AC. So let's try to draw the right bisector of AB. And if you really want to be precise, you can measure the length of AC, and then you'll be able to find the midpoint much better than what I did. But you know what? I can live with what I have. So once again, if you draw the right bisectors nicely, then you'll see a point where the right bisectors intersect. Now, where the right bisectors intersect is a very special point. Once again, it has significance in terms of its application in geometry. So we have a name for this one too. It's called the circumcenter. Circumcenter, very, very nice point. Okay, one more to go. Altitude. Now, altitude you should also be very familiar with. Okay, essentially, altitude, when I think of the word altitude, I think of a plane that's flying, and I ask myself how high the plane is. But altitude, basically, if you think of how high, height, this is the height of the triangle. Okay, so line segments from a vertex that is perpendicular to opposite side. Okay, so the median has to start from a vertex and the altitude has to start from a vertex, but the perpendicular bisector does not. Okay, so really it's just the height of the triangle. So if you ever forget, altitude is just the height of the triangle. Okay, but you have to go through a vertex. Right bisector doesn't have to go through a vertex. So you can pause the video. And you guessed it probably. The altitudes of the triangle also intersect at a point, and that's called the orthocenter. Okay, we'll talk about the orthocenter, the centroid, and the circumcenter later on. But to be honest with you, the circumcenter and the centroid we'll talk more about compared to the orthocenter. Okay, so like I said, it's really important that you're able to draw the median, the right bisector, and the altitude, because the math won't make any sense if you can't draw it. So now that you can draw it, let's try to do the algebra involved with the median, the right bisector, and the altitude. Okay, so now we are ready to find the equation of the line containing the median and the altitude, and find the equation of a right bisector. Just a small little comment, the median and the altitude are line segments because they're line segments drawn inside a triangle, but the right bisector is actually a line, not a line segment. That's a very small detail. This first page is actually devising a strategy which you can use to find the equation of the median and the altitude and the right bisector. But you know what? I actually want to just do the math first, and then we'll come back to the strategy. Okay, I don't want you to just memorize like step 1, 2, 3, step 1, 2, 3. I really want you to understand what's going on. So let's actually do the examples first. So we'll come back to this page. Okay. So we have triangle ABC with vertices ABC, and they gave us the points. And they want us to find the equation of a line containing the median from vertex A. So usually, I have the students just plot the points, but to be honest with you, you don't really need to plot the points. You don't need a very, very beautiful picture. So I really want to test your understanding. So I'm just going to just draw a random triangle, okay? The A, B, and C are irrelevant, to be honest with you. Okay, so let's say A, B, C, okay? So we want to draw the median from vertex A. So remember, median from vertex A means you start from vertex A and you join the midpoint of the opposite side, which is BC. Okay, so how do you find the equation of the line that contains the median from vertex A? Well, you know what? We actually need something from the previous unit. So let's think about it, okay? To find the equation of a line, I need 2 points. Well, I have 1 point. What about, oh, if I find the midpoint of BC. Okay, this is a strategy, okay? So with the diagram, you just stare at the diagram and the answer comes to you. Find the midpoint of BC. Once you have the midpoint of BC, you can find the slope of the median. Once you have the slope of the median, you can find the y-intercept of the line that contains the median from vertex A, and then you're done, right? It's really a combination of the midpoint formula that you learned from last unit and then some grade 9 skills, right? That's why we reviewed how to find the equation of a line. Once you have 2 points, bam, grade 9, okay? So really, the first step is grade 10 and the rest is just grade 9. So the midpoint of BC, oh, you gotta remember that formula, right? Average the x coordinates, average the y coordinates. So -3 plus 1, 7 plus -5. Okay, and of course I know these points are not positioned correctly based on what they gave us here in terms of the coordinates, but I really want you to generalize. This is the strategy. Every single time you're asked to find the median from vertex A, you can just draw a triangle and draw the median, and then you'll be done. Anyways, -2 divided by 2, 2 divided by 2, bam. Okay, so this point here I have. The midpoint is -1, 1. The vertex A I have as well. So guess what? I can find the slope of the median. Okay, so I'm going to sub in this point and this point. So 2 minus 1 and 5 minus -1. That will give me the slope of the median, which is 1/6. Beautiful. I have the slope. I can sub in either point. So y equals mx plus b. Let m equal 1/6. Sub in. What do you want to sub in? You want to sub in the midpoint? Or do you want to sub in vertex A? Does it matter? Nope. I'm going to sub in the midpoint. Okay. So this will go negative plus, so 7, 6 is B. Take your time. Don't skip steps like I do. There we go. We have the slope. We have the y-intercept. So let's do a nice little therefore statement. The equation of the line containing median from vertex A is y equals 1/6 x plus 7/6. Okay, so remember, so you're really finding the equation of the whole line. Okay, and you see this line contains the median. Okay, so remember, this is a line, but your median is a line segment. So it's always going to be phrased like that. Okay, the line containing the median, because once again the median is a line segment, but you're finding equation of a line. Anyways, that's it. Now, if you didn't feel comfortable with what I did in terms of just drawing some random triangle to help me with this question, go right ahead. Plot the points nicely, draw the Cartesian plane, do what you need to do to help yourself out. But I really want you to understand this is the general strategy. Okay. by drawing a random triangle, it really helps us to answer this problem. So we have another triangle, ABC. Find the equation line containing the altitude for vertex C. So I'm going to use the same strategy. I'm going to draw a triangle. Okay. So this time it's the altitude from vertex C. Okay. So how can I find the equation of a line containing the altitude of vertex C? So let's to find the slope of this line, I should find the slope of this line, right? Slope of line AB, and that will give me the slope of the altitude because they are negative reciprocals. And then I can sub in point C, because with a slope and a point, I can find the equation of a line, right? So slope of AB is equal to negative 8 minus negative 1, 1 minus negative 6. So this is going to be negative 7 over 7, which is negative 1. Now if the slope of AB is negative 1, the slope which is perpendicular to AB must be positive 1, because negative 1 and 1 are negative reciprocals. Beautiful. Okay, so y equals mx plus b. Let m equal 1, and we are going to sub in. Now, unfortunately, this time we have no option. We only have one point on this line here, on the line that contains the altitude. The one point is vertex C. No problem. We don't need a choice. We just want to find the equation. Bam, b equals 1. Therefore, the equation of the line containing altitude from vertex C is y equals x plus 1. Beautiful. Once again, it's the line containing the altitude because the altitude is a line segment. Okay? Alright, last one, right bisector. So, this time I'm not even going to draw a triangle. I'm just going to draw a line segment AB. How do I find the right bisector of AB? Who cares where AB is located on the Cartesian plane? How do you draw the right bisector of AB? Well, remember, to find the equation line, you just need the slope and the point, right? So if I find the slope of AB, I take the negative reciprocal, that gives me the slope of the perpendicular bisector. Find the midpoint of AB, that gives me a point. Okay? So slope of AB, midpoint of AB, that's what I'm starting off with first. You could easily find the slope of AB first. 4 plus negative 6 over 2, 4 plus 2 over 2, negative 2, negative 1, 2, 6, 3. Okay? And then the slope of AB is 2 minus 4, negative 6 minus 4, negative 2, negative 10, so it's 1/5. Therefore, the perpendicular slope is negative 5. Okay, so guess what? We have a slope, we have a point. I think we are good to go. So let m equal negative 5, sub in the point negative 1, 3, and we're golden. So this is 5, bring it to the other side, negative. So 3 minus 5 is negative 2. Therefore, equation of perpendicular bisector of AB is y equals negative 5x minus 2. Okay, there we go. So just a small little point here about the right bisector. Like I said, the right bisector of a line segment is not a line segment. Okay, it's a line. So that's why is that we don't say containing blah blah blah. Okay, it's just the right bisector of AB is boom, y equals minus 5x minus 2, because your right bisector is a line as opposed to a line segment, which the altitude and the median is. Okay, so as I promised, I'm going to go back to the first page. So, and like I said earlier, really, if you can draw it, you can make sense of the algebra. You're just like Sherlock Holmes. You're slowly like, what do I need? What kind of properties must be true? And then slowly piece it together from there. Okay. So find the equation of the line containing median from vertex A. So you know what? I'm just gonna sketch it out first. Okay. That was ugly, but you know what? We can live with that. You know what? We can't live with that. Alright, let's see. Okay, a bit better. Okay, so the strategy for finding the equation median from any vertex is find... I mean, there's really one thing you can do. There's nothing else you can do, which is find midpoint of BC. There's nothing else you can do. And once you find the midpoint of BC, the really only thing else you can do is find slope of median. There's nothing else you can do. And then find y-intercept. Because once you have the slope, you need to find the y-intercept to complete the equation on line. Okay? So really, the diagram really tells you the steps. If you ever forget, and by the way, you should never really memorize the steps, just draw the diagram. Okay, I always encourage students to draw the diagram. Okay, find the equation line containing the altitude from vertex C. This one's a little tricky. We'll go with that. Okay, not pretty, but we'll go with that. So, what do? How do you find the equation of the altitude from vertex C? Find the slope of AB. And if you find the slope of AB, you will then find the slope of the right bisector. Oh, sorry, the altitude from vertex C, because the two are perpendicular to each other. So I don't even know if I consider that as an extra step, but find slope of altitude, and then find y-intercept using point C, right? For this one, for the first one, you can say find y-intercept using, instead of saying point, say vertex, using vertex A or midpoint of BC. I really don't want to give you too much into the step, because I really want you to use the logic of the geometry. Okay? If you know how to draw it, really, it really pieces itself together. It's like a puzzle, and it works so beautifully. Okay, last one, they want me to draw the right bisector of BC. Oh, sorry, they want me to write down the steps. Okay, so find, let's say find slope of BC and take negative reciprocal. And then find midpoint of BC, and then find y-intercept using midpoint of BC. Once again, this one you don't have a choice. You only have one point on the line, which is the midpoint. But that's all you need. You don't need 2 points. You just need 1 point. So find slope of BC, take negative reciprocal, because that will give you the slope of the perpendicular bisector. You need a point to help you find the y-intercept, and the only point you can really find is the midpoint of BC. And that's it. Okay, so first things first, understand the diagram and how to draw the median, the right bisector, and the altitude. And once you can do that, the algebra really just flows. There's really one strategy. Like there's no way of being creative here, unfortunately. Like for the median, you have to do those 3 steps in that order. Now the one that has a little bit of creativity, I guess, is the right bisector. I guess you can find the slope first, or you can find the midpoint first. But once you do these 2 steps, you have to do the 3rd step. And I would argue of the 3, the altitude is the easiest. It's the shortest. And I would argue the median is the longest, but not by much. They're all pretty straightforward. Okay, so this is a great sheet to practice your ability to define the equation of a line. And this is also good on reviewing your midpoint formula from the last chapter.